Hmm. What's up, duties? Let's be chill. Everyone's here to talk shit. Did you do the plate from scratch, or did you use Swell? Are there 2 streams? Let's watch together. Oh, I see. Yeah, I usually start with Swell and then just change things. Especially the stab cutouts, and then I just add, I don't know if the relief cuts actually do anything or not, but... I had a previous stream where I built my TGR Alice. This keyboard right here. This was designed by Yuxi on Geekhack. Yeah, so I just soldered in the switches basically and did some test typing on the keyboard. That was my only previous stream. It'll get there one day, Zach. Budsy, did you get your Alice yet? No? Oh, that sucks ass. Maybe in a few weeks. Oh, like re-anodized? Okay. So is he just getting them stripped and re-anoded? Are there any rules against posting streams in the Top Clack Discord? I haven't read all the rules. Does anyone know off the top of their head? I'll just ask before I post it and see if Quakeums are man of interest. I don't have anything against it. Let's just say I'll start at 10:15. It's probably good. Just wait a few more minutes. Is this the QXP ship? Yes, I'm going to be packing your boards and shipping them during the stream. Yeah, the Alice does sound really good, but I mean, anything with blacks in 205 G0 sounds really good. Yeah, beginner's tutorial for Fusion 360. I think we'll make maybe some circles or... Oh, the fan's loud. Alright, I'll just turn it off. Is the fan less loud now? A little concept I made. Has this been done? Let's see. Oh. I don't really use wrist rests, but that's pretty cool. Alright, we'll get started in about 40 seconds or so. because Zach, Ortho, and Plank. Actually, when I first got into mechanical keyboards, one of the first keyboards I saw on battle stations was the Plank, and it was actually pretty cool, not having seen like any custom keyboards before. So all right, let's get started. I'll refresh this and start from scratch. So I'm going to be doing a 65% keyboard design for today. If you guys don't know what that is, I'll just do a lookup real quick. Some examples are the White Fox keyboard. So this is a 65% White Fox. There's a few other layouts. No, I'm not making a TKL TIFF. I'm going to make a 65%. Yeah, so the layout is basically like this. So the first thing I do is I go to Keyboard Layout Editor, and I just get the closest thing to what I'm designing. So I'll just start with a default 60%. Oh, Shill Q. I don't know. Yeah, so here's 65% keyboards. Here's one that I have designed in the past. This is called the Q. I'm going to be making a keyboard pretty similar to this. It'll have a blocker in the top corner, it'll have the blocker by the arrows, and it'll have a blocker here. Alright, so let's get back to actually designing the keyboard. So I'm just going to change this layout to be representative, to represent what I want. The legends don't really matter, so they might be wrong. So I'll use a 7U spacebar. These ones over here will end up being my arrow keys. And then I'll do a short right shift so we can get the up arrow in there. Yeah, so that's basically what our layout is going to look like. A few other things we'll add is we'll do a step caps lock, and then we'll add split backspace support. So at this point, I grab the raw data. So that's just under the raw data tab on Keyboard Layout Editor. And I paste that into the plate layout. Stabilizer type doesn't really matter because I'm not going to use the stab cutouts generated by SloKB. I prefer switches that don't have switch top removal. I think the plate feels nicer, so that's what I'm going to do. So it just draws the CAD for you, and then I save that as a DXF. So that's downloaded. And then we'll go to Fusion 360. We'll click Upload, select Files, just grab that file we just downloaded, and we will upload that. Yeah, Coffee, I think I saw some of your renders. You did the renders for the Mr. Sleeves group buy, right? So this is like a brand new blank document. You can just go to File, New Design. So for sketching, I use this plane when I'm designing keyboards. It's just what I'm used to. It's not better than any of the other planes, just a preference. So we'll open that switch plate file. Something weird that Swill does is the scale's not actually right. So if I do a measurement right here, it ends up being 10 times too large. So to fix that, we're going to scale the design. So we select everything. And then we deselect a single point in the corner. I'm going to use... What is that command? So one of the shortcuts I use a lot is pressing the S button. So that basically just lets you search for things. So I'm going to use sketch scale. So I already have everything selected that I want to scale. And then at that point, you just have to choose a point to base as your reference for the scale. So we'll do 0.1 since everything was 10 times too big. And we have a plate. So I'm just going to select that. Copy. Go to my other design. Paste. Those are just Control-C and Control-V in Fusion 360. So at this point, I'm going to clean up the stab cutouts because they look like ass. So usually I end up just drawing a rectangle around the cutouts that are already defined. Oh, I messed the other one up. All right. And then I delete the old geometry. Don't need it anymore. Alright, so we've done one of the 2U stabs. Instead of doing the circles again over and over, I just delete the old stabs. Make a nice box. And then I'm going to select these two. Alright, so now we just need to move these stabs over to where they actually go. So keyboards are built on a 19.05 grid. So if we do 19.05 times, I can't remember how many keys exactly it is away, 12, so just move it over until, eventually you'll know. All right, so 12.75 units to the right, and then up, we go 19.05 units up. And there we go. We have the stab cut out here. And then we'll do that again, just another paste. Times 13. Okay. Oops. Sorry, I put that one in the wrong place. We'll do that again. Sometimes Fusion 360 lags a little bit. I don't know. It's not the greatest program, but 0.8. All right, so now we have that stab. The next thing we want to do is add the switch cutouts for the split backspace. So we'll copy paste and then we'll move one that way, and then the other one goes this way. And then I normally like to clean this up. So you just delete all the geometry you don't need. There, there. And then we just close it. Oh, missed one. All right, and then that's the split backspace cutout. Now we can do the stepped caps lock. So I'm pretty sure, go negative, and then there's the cutout for that. We'll delete the extra geometry again. What's up, Tonka Tonk? Just doing step caps lock right now. All right, and then the last thing we'll do is we'll do the stab cutouts for the 7U spacebar. A little different from the other ones. We're gonna flip these upside down actually, so I'll show how I do that. So again, we'll just do the box outline. Delete the extra stuff that we don't need. Close off this box. All right, so now we want to flip these upside down. For this, I usually use the mirror. So I select the geometry that I want to mirror. Oh, let me close this stab actually. All right, so we'll do the mirror. We'll select, and then we'll select our mirror, which is the middle of the switch, to flip the stab upside down. And then we'll delete the old stab. So the reason I delete everything is if you have too much geometry in Fusion 360, it actually ends up slowing it down a lot and it gets really laggy, which is kind of annoying. So I try to clean it up as I go. And then if you want some like Mimi relief cutouts, those are pretty easy to put in. So I just draw a line from the middle of the switch, and then in the middle of that I draw a circle. And then we'll go this way, say 10. We'll do 1.5. Create a line again, and we're going to do the mirror again. So we'll select this. We'll do the mirror. We'll select the line for the mirror, and then that'll be duplicated across. All right, so this is going to be our plate. So in between the edge of the case and the edge of the switches, so all the switches are on a 19.05 grid, as I said earlier. So if you do like an offset of minus 2.525, I guess they changed that in the latest update, but if you drag it this way and do 2.525, you'll see that it's on in a perfect line with like the edge of the switch plate generated by SwillKB. So if you actually set the edge of your case to be on this line, you'll get a problem. You'll run into a problem when you get it manufactured where the edge of the keycaps will actually hit your case, which you don't want that. So what I do is I create some space using the offset tool. So if you just press O, that's your offset. So you select that, and I do a 0.475. So that's going to be the space between the keycap, like one switch unit, and the edge of the case. And then after that, we define the outside of our case. So bezel-wise, I usually do somewhere around 6 millimeters. So we'll do 6.475. The 0.475 comes from the offset between the switch unit and the edge of the case. So yeah, that'll give us a 6 millimeter bezel. And another thing that I need to add are the blockers for the switch. So like I showed you earlier with Q, which is this keyboard right here, you see there's a blocker here, there is a blocker down here, then there is a blocker over here. So we're going to replicate all of those in this drawing. All right, so to do that, like I said before, we're on a 19.05 by 19.05 grid. So we select the key that we want to block out, and then we go 2.525. Why 2.525 though? All right, so if we go to a calculator, and I said we're on a 19.05 grid for each switch, so we do 19.05. If you read the specification sheet for a Cherry MX switch, so I'll just pull that up real quick. We'll actually reference this later as well. And you look at the size for a switch, it's 0.61 by 0.61, right? And if you go to the key switch metal frame cutout dimensions, so metal frame meaning plate in this case, you have a 0.551. So this is all in inches, so we need to convert to millimeters. So 0.551 inches to millimeters, and you get basically 14 millimeters. So you're on a 19.05 grid, you have a 14 millimeter switch cutout. Will you save this stream in your videos? So yeah, I'm actually recording this stream. I'll save it to my videos, and I'll try and upload it to YouTube as well so you guys can watch it later. So you get 5.05 for that. 19.05 for one switch unit minus 14 for the size of a key switch cutout. And then you divide that by 2. And that's my offset because it goes in both directions. Okay, so now we have that. That's one switch unit. So another dimension that we have is the size of a keycap. So the size of a keycap is 18 millimeters. That's for a GMK keycap. I'm not sure about SA. And I think Enjoy PBT are actually a little bit smaller than GMK. So if you do 18 minus 14 divided by 2, that's 2, right? So for my blocker, I want it to block the same exact size of a keycap. So I'll offset that by 2, which is this in here. And at this point, I'll delete the switch and that cutout, and then I'll just extend this blocker all the way down to the edge of the case, right? So this is part of the case. This is part of the case. This right here is the space in between the edge of a switch unit and the edge of the case so that your keycaps do not end up hitting your case. And then I'll just drag that down too. All right, so we have one blocker right here. Next, we're going to do the blocker that goes here in between your arrow key and your key just to the right of the spacebar. So this will end up going exactly in the middle of these two. So it'll be centered off right here. If we look at the keyboard layout design we did earlier for the KLE layout, if you move this over 2, so you know that it's 2 units, right? And a full unit this is a full unit, which is 19.05. So the size of this blocker is going to be 19.05 divided by 2, right? 9.525. And then for the actual size, we want it to be the size of a keycap divided by 2, which is just 9. So the size of this blocker will be 9. So starting at the center, we'll go up, and the height will be 18 for the size of a keycap. Just do a line straight up, 18. And then each way we'll go 9 divided by 2 that way. And we'll do 9 divided by 2 again that way, which is 4.5. And then the last thing we need to do is the blocker in the top right corner. So we'll do a copy paste. We'll go up 19.05 units for the size of a switch. We'll offset that by 2 because the size of our keycap is 18. We'll extend that to the case. And there we go. That is our plate. I'm going to go in and delete these because they're confusing. And then just close this again. All right, so let's save. And at this point, we can extrude. So usually the first 2 things that I extrude are the top of the case. So we'll select that, which is our outer bezel. We'll select the blockers that we created. Oh, so I made a mistake. I didn't extend this blocker all the way to the edge of the case, but we can fix that really quick. So we'll get this blocker for the top right, and then we'll get this last blocker right here. So for the height of the top of the case, I like to do 7.5 millimeters. 7 millimeters, you can kind of see under the keycaps. I don't really like seeing under the keycaps in my designs, so yeah, I go with 7.5 millimeters. That'll cover the bottom of the keycaps and give you a nice look, in my opinion. So sometimes Fusion is really annoying, and you just, for some reason, there's like some extremely small portion that doesn't extrude properly. So one way to fix this is you just go back in your history and you just scroll in and you just find that little section that didn't extrude properly, right? And you just click on that and you can zoom back out. And there we go. We have the full top of the case. So the next thing to do is to create the bottom of the case. So I create a sketch from the side of the case right here, right? And then I just draw like a giant square. So like, I don't know, 50. And then you need to decide the amount of space that you need for the bottom of the case. So to figure out how much space you need underneath the case, so underneath this, right here, you have your plate, right? Your plate is usually 1.5 millimeters thick, or at least it will be in this design, right? So your plate's going to be 1.5 millimeters. And then underneath your plate, you can like read the Cherry spec sheet and deduce how much space you need underneath your plate for like the PCB, etc. So if you go and you look here, you see from the top of your switch plate to the top of your PCB, you need 0.197 millimeters, right? So, or 0.197 inches. So 0.197 inches to millimeters. All right, Google. So that's 5 millimeters. And then what's the thickness of a PCB? Usually for keyboards, the thickness of a PCB is 1.6 millimeters. So 1.6 plus 5 is 6.6 millimeters. But you'll notice if you've bought a PCB in the past that the little legs on the bottom of the switch, I don't know if you're going to be able to see this, but actually it'll be easier if I just pull up what a switch looks like. Thank you, Google, for auto-completing everything. Yeah, so these little legs right here, if you actually put those into a PCB, you'll notice that they stick out a little bit from the bottom of the PCB, so you need a little more space than just the 6.6 millimeters. So for safety, you could do something like 7 millimeters or something like that. So underneath so from the top of the plate, which is right here, you'll need about 7.5 millimeters or so. You can probably get away with 7. I've done that in a few designs, but it gets a little tight, so I would recommend doing 7.5. Yes, Q Protos were very tight. They were 6.5 millimeters. So yeah, that's why. So the next thing we need to decide is our angle. Angle is something that is really just up to the person. Some people like 12-degree keyboards. That's what Duck does. Some people like 0-degree keyboards, just a flat board. Personally, I like it to be somewhere from 6 to 7 degrees. So for this one, I'm going to do 7 degrees. Also, no, I'm not doing 11. The keyboard's called Nana, which means 7 in Japanese, so we will do 7. Yes. It's been decided. So, something I'm going to change from the sketch I did earlier, or the first extrusion that created the top of the case, like this part. So, something I didn't account for when creating this is that I want this keyboard design to actually be top mount, right? So the edges of the case need to go around the plate. So to do that, we need to take our 7.5 millimeters, which will cover the bottom of the keycaps. So 7.5 from the top of the plate to the top of the case will cover the bottom of the keycaps, but what it won't cover is the PCB, or sorry, the plate. So the plate is another 1.5 millimeters, right? So you want the plate to sit like somewhere in here, but you can't do just 1.5 millimeters, right? Because you also want to cover the screws that screw the plate into the top of the case. That'll make a little more sense later, but one thing you can do is you can go on Amazon and you can look at like a hex cap M3 screw. Sorry, they're called, what are they called? A head cap. And we'll just do like 5 millimeters or something. And you'll see like a screw like this, right? So just looking at this little piece of the screw is going to stick out. So your plate, the bottom of the plate is going to sit right here, and this part of the screw is going to stick out from the plate. So you want the case to cover this as well. So you need to know how tall, what is this dimension right here on the screw? So usually they'll list it somewhere in the specs. So if we look at head diameter and then we have total length, so the diameter of the head, the total length of the screw is 7 millimeters. That means from here to here is 7 millimeters. And this 5 millimeters is the size of the threading, so we know that the head of the screw right here is 2 millimeters. So to cover that, so we have 7.5 to go from the top of the plate to cover the keycaps, 1.5 to cover the plate, and then we'll do another another 2.5 to cover the screw. All right, now we have that. We'll delete this sketch from earlier since it's in the wrong place. All right, now we can do the actual bottom of the case. All right, so if you remember earlier, we have the 7.5 for the top of the case. We have the okay, and then from here, we need another 7.5 millimeters. If you remember my talk earlier about the space you need for the PCB to fit underneath. And then from there, you can angle. I said the angle would be 7 degrees. And then we just draw a line straight down. And then there we go. Right, so this is going to end up being the bottom of our case. Actually, one sec. So 7.5 is the space you need. Usually you want to make it a little bigger because you don't want there to be, if you make it just 7.5, then the PCB will be like flush with the bottom of the case and there won't be any space that go for the in between the PCB. All right, so now we'll extrude that. And we'll just extrude it all the way. I don't know, I used to use 2Object a lot, but that doesn't seem to work anymore. It actually gets kind of annoying. So the lazy way is to just extrude it too far. We want it to be a new body, right? And then we can just create a sketch on this face. just do a line, or sorry, we'll do a rectangle and just encapsulate this area and just delete it. Boom. Nice. We have our beautiful boxy keyboard. It looks just like an X60. I mean, no, just kidding. All right, so the next thing, Mr. Kim. Who's Mr. Kim? The next thing we want to do is we want to cut out a chunk from the bottom of the case for the PCB to fit into, right? So we'll go to our bodies, we'll hide our top. I'm going to name these real quick. Gets a little easier when you start hiding things. NK is streaming too? Damn, are we competing? Who has more viewers? I bet he has more viewers. I'm gonna go yell at him for stealing my stream time. Yeah, my beard's not really that trimmed, so I guess it's all right. It's been better. Yeah, so getting back to it, let's make room in the bottom of the case. Watch Quantric or Kim. Why not both? Just put them both on 2 tabs side by side. So we'll extrude this way to cut space out. We obviously don't want to cut out the bottom of the case so we can't see anything. So we'll do a -4.5. That might be a little close. We'll do a -4. All right, so now we have a space cut out of the bottom of the case, and that's where the PCB will sit. Let's go clean up the top of our case. Who's North Korea? I don't know. Who's South Korea? So if you remember back to, well, you don't have to remember, I'll show you this sketch right here. So 7.5 is from the top of the plate to the top of the case. So basically from this point upward, we want to cut out of all the blockers so that the plate has somewhere to sit. All right, so let's go back to that sketch I just started, or didn't start. All right, so we'll create a sketch here. We'll create a rectangle that basically captures all of the blockers, right? So we want to remove everything but 7.5 millimeters. So if you measure this, you see 11.5 millimeters, and you want to cut out the 4 millimeters that are extra, right? So we'll do a -4, and we'll cut those away. So basically our plate will sit up right here, and the PCB will sit underneath the plate. So if we measure this distance from here to here, we have 8 millimeters. So remember what I said earlier, you want somewhere around 7.5. If we want to make it exactly 7.5, we can just change that extrusion we did to cut out this chunk from the bottom of the case. So if you just double click on that in the timeline, I can just make it -3.5 instead of -4. And then if we do that measurement, there we go, 7.5 millimeters, exactly what we want. All right, next let's create the plate. So we'll go back to our beginning sketch right here, and we'll just extrude all of this goodness for the plate. So our plate thickness is going to be 1.5 millimeters. So right now we have a little bit of space in between the plate and the blocker, 2.5. So what we can do is just, let me rename this to plate real quick, and we'll just do a move. To move, you can just press M, and we'll just go up. What was it, 2.5? I think that was right. So yeah. Now you have your plate right up against the top of the case. Yeah, the relief cutouts are kind of ugly, so we can do a fillet. What happened there? That's hideous. All right. I'm gonna go back and fix this relief cutout because it looks terrible. I probably just messed up one of the dimensions, to be honest. So if I distance that, 10. Okay, this one is not 10. So I'll just change that to 10. So what happened there was it actually pulled all the other geometry, which is kind of annoying. So what we can do is we can fix this circle. So then this is ground, it can't be moved by anything. And if we make that 10 again, it'll actually pull it in that way. So we'll do the same thing over here and fix that shitty stab cutout. Actually, we don't have to fix it over here because the geometry was mirrored. So if I fix it on one side, it'll actually fix it on both sides. So we can just do a sketch, stop sketch, and it will replay all of the history. So if I go back and edit this sketch here, it'll redo all of these steps based off the change I made. Who's kind of annoying, Amnesia? Mods. You're right, we should have a mod. Let's see. Zek. How do I make someone a mod? There you go. Zek, you're a mod. Good luck. Be a good boy. Alright, let's fillet this. We'll fillet there. And there, and there, and there. There, and there. And we'll fillet by 1. That looks kind of ugly. Bigger, 1.5, and you get a nice round relief cut. Yeah, I don't know. You can make them look however you want. It's not that big of a deal. And there we go. We have some nice Korean relief cuts. So another thing, oh, okay, I guess it didn't happen. So if you see this green point in the middle, that's your like reference point for where you orbit. So if you like set the orbit center over here, and I don't know, sometimes when you orbit, it doesn't orbit the way you think it will. So what you can do is just reset the orbit center, and it'll set it to the center of your geometry. Yeah. All right, so let's go back. So we have our relief cutouts. Let's make this thing less boxy, I guess. Fillet. So let's round the outer corners. This is really a preference. It's up to how you want to design it. So you could do 2 millimeters, you could do 4, you could do 6, you could do 8. It's really up to you. For this one, let's just do 4. And then another thing is chamfer. So once you round the corners, you can create a chamfer, and so you just get that nice look. And you try and avoid having a lot of sharp corners on your design, right? So there you go. You have a chamfer, you have rounded corners. Now let's do the inside. So we'll do another fillet. We'll select where we want to fillet. We'll do there, there, there. Basically all the inside corners of the top of the case we will fillet. A few more to click, and I think that's all of them. And then we'll do a chamfer on the inside, 0.5. So one thing that tells you if you've actually filleted all of your corners properly, if you do a chamfer, then it'll actually highlight the entire inside edge. And if it's all highlighted, that's how you know that all of your corners were filleted properly. So yeah, then we have 0.5. And then obviously we want the rounded edges of the top of the case to match the bottom of the case. So we'll do the fillet again. And if you recall, those were also 4 millimeters. So we'll do the 4 millimeters and they line up. Great. So something we changed was we rounded these inside corners on the top of the case. We'll also round those on the plate. So we'll do that fillet again. We'll go to the 4 corners of the plate. One millimeter, right? And then the last thing we need to do is the bottom. All right, so now we're filleted all the way through and everything should be, yep, you can see it. And then this is the space between the plate and the edge of the case. Koala bottom. No koala bottom for this one. All right, so at this point, I guess I'll design the bottom of the case. I guess this is a sneak peek since I haven't really told anyone how I'm going to design this for the Nana. So if you remember from earlier, the angle of our case was 7 degrees. So when I work on the bottom of the case, I like the bottom to be flat against the plane that I'm working off of. So I just rotate everything 7 degrees, like that. And then I'll sketch here. So on this design, I think I'm going to cut in this way, so I guess I'll just show you. But some data points I need to do this are this line right here. Because if I cut the case in this way, and I guess I'll just show an example of what I don't want to happen. So if I offset this by 1, and we just go straight down, and I extrude this geometry, and we go in sideways like this. Like, you don't want your case to look like this, right? You don't want that to happen. That looks like shit. Looks ridiculous. So what you want to do is you take this reference point, which is the bottom of the inside of the case, and you go down, right? Let's go down like 0.5 millimeters or so. So for this design, I want it to come in a bit this way, maybe like 20 millimeters. And then I just want it to go up. And just follow the angle of the case. And the angle of the case is 7 degrees, right? So we'll just do 7. So I know I made these filleted earlier, but they're kind of annoying when I'm trying to redesign the bottom of the case. So for now, I'm just going to delete them. So yeah, we have this portion that I want to cut out from the bottom. So I'm just going to extrude this in, let's say like -20, right? And then another thing I want to do is I want to pull this in as well, right? So there's space here. That actually looks a little too big. I'm going to change that. Let's do 10. Yeah, 10 is good. So I want some space here, but I also want space here. So we'll do another sketch. we'll project this geometry, and then we'll just offset it. Let's see, 10, no, 10's too far. I just want to offset this line. So to just offset the line, you can just click the line, and we'll offset that. We'll see how 5 looks. I think 5 should be good. And we'll just cut this one out all the way through, right? So now yeah. I think it might look better if they both match. So we'll just make this 10, and if it looks ridiculous, we can always make the other one smaller and meet in the middle. Yeah, that's probably a little too big for my taste, so we'll just do 7.5. And then for this portion, we'll just go in 7.5. So then if you go look here, it should be 7.5 from both places. So if I go and do a sketch on this lip, and I go this way, it'll be 7.5. If I go this way, it'll be 7.5. And my cat is meowing at me. Great. So we'll create a sketch on the other side to do the cutout. We can actually copy the sketch we did earlier so we don't have to redraw it, and we can just extrude that, and we'll do another minus 7.5. That is a cat, not a human. How thick is the space between the inside corner at the bottom and the inside corner in the tray? You mean the space from this point to this point? Is that what you're asking, Amnesia? Yeah? So that's 3.336 millimeters. No, it's pretty big. Show cat. All right, I will show cat. This is cat. All right. I guess she wants to get out of the room. No, get out. All right, she's not gonna get out because my dog's waiting to attack her. All right. Let's go back to nice, good cat. The cat wanted to go outside the room until she saw that my dog was right outside the room waiting for her. All right, so we'll do 4, 4, 4. Yeah, we'll do 4 for all of these. Like that. Look at the top. So I want to add some chamfers to this part. I'm just going to leave it at 1 for now. And I'll do a chamfer here as well. Yeah, so if you want to mess around with colors, you just press A. I have some saved ones, so if you want like blue, just make the case blue. Yeah, but we're getting ahead of ourselves. 45 minutes, I mean, we're not done. A few things left to do are, I started at, I think, 10:15, so it's been about 51 minutes. We have to do the mounting for the plate. We have to do the screw holes, so the top and the bottom mount together, and then I'm going to add a weight to this. I have a design in mind for the weight already, so yeah, let's do that next. So I'm going to undo this rounding because I want to do the weight design. Who do I use to manufacture my cases? I use a Chinese company. I will not reveal their name. Alright, so I'm gonna do a rectangle. Height will be 5, distance from here, we'll do 10. So this is just weight design. It really doesn't affect any functionality of the case, it just makes it heavier. Yeah, so I have that, and I'm just gonna cut it out from the bottom. So instead of cutting, actually, like I should do this a little differently to make it better. So we're gonna do an offset plane. If we go to the origin, we'll show that, and we'll do an offset from here. So we'll go back here about, and we'll do the sketch on this offset plane. All right. So I'm gonna project this square. Send me the CAD and I'll give you Premium rendered free of charge. Enticing. I like this coffee guy, straight to the point. Render with a computer. So we'll do the 10 again. Same here. What is this line? I don't want this line. I need to delete this dimension. All right, now we can do it. So let's just cut a chunk out of this. So instead of just cutting a chunk out, there's a feature you can use called intersect, which will create a part from the intersection of the two pieces. But if we do this, then we lose the bottom of our case. It's now just this bar piece, right? So the first thing we want to do is we'll stop the sketch and we'll make a copy of the bottom. Reset orbit center. And the first thing we'll do is we'll hide this extra bottom. We'll do a cut. And I think I made that cut 45. So now we have the space cut out for the weight. So now we can re-show this bottom and we can re-show this sketch and we can do the same 45, except this time we'll do an intersect. And there we go. We have our weight and we have our bottom. The new Clippy weight, I actually have not seen the new Clippy, so yes, maybe I am copying the new Clippy weight. So now we can re-add in all of our nice fillets. And we'll re-add the chamfers. I think I did 0.5, and then we'll chamfer this again, which was a 1. And then why did the fillet? I actually deleted the fillets earlier, Kana Joe. So when I went to do the weight design, I deleted the fillets, so I had a reference to the edge of the case. No, I didn't jump back in the timeline. I deleted them and then I remade them. So to mount this weight to the case, there's 2 ways. One, okay, fucking cat. Yeah, no problem. Feel free to ask questions if anyone gets lost. Weight looks kind of small. Yeah, so basically we can do the screws up through the bottom of the weight into the case, or we can do them down from the inside of the case into the weight. So if we do it down, we can actually hide the screws so we don't see them from the outside, and the design will look, in my opinion, cleaner. I guess people are saying that the weight is small. I don't know. Maybe I'll go back and make it bigger. If you want to know how heavy something is going to be, we pretty much have all of the material, right? So the case is going to be pretty similar to 6061 aluminum. So if we just drag that material on, and then we drag on, I don't know, brass for the weight, and then we select it. Oh, forgot to do the plate. We'll do that as brass as well. And we just do properties. We'll see that the total mass is 1.2 kilograms. I mean, it's not the heaviest case. It's not the lightest case. I don't know. I could go and make it heavier later if I wanted to, or I could leave it. It depends. So yeah, we'll do the mounting for the weight now. So I'm going to do it from the inside, and the screws are going to go down into the weight. So I want to see, when I do these screws, actually these names are confusing. Let's rename that to weight. And then let's project that onto our sketch. So this is where our weight is. We probably want the screws to go into the middle of it. And I like to use M4 screws. So an M4 screw usually has an 8mm head for a countersunk screw. For those of you that don't know what a countersunk screw is, I can go to Amazon and countersunk M4 screw. Right, so this is a countersunk M4 screw. If you look at the specs, so the head size is 8.1 millimeters. So I guess I can make this 8.1. And then usually I just use some like set number distance, like increments of 5. 15 millimeters from the edge is probably good. Do another 8.1 millimeter screw. And then we'll just put that in the same place. Since this weight is pretty small, as other people have mentioned, you probably don't need a screw in the middle. If you had a bigger weight, you might want a screw in the middle, but this will probably be fine. All right, at this point, we'll do a hole. We have a countersunk. So we'll select our 2 points for our countersunk screw. If you remember earlier, this is the depth of the screw. We'll adjust that in a bit. First, we'll do the size. So this is 8.1. And then the size is M4. So 4 millimeters. And then to get the depth, so 10 is probably a little too deep. We'll do 9. Since most machine screws are flat on the bottom, you can leave it flat or you can leave it pointed like this. If it gets a little close to the edge, like this, you might want to make this 180 and just make it flat and then put like an 8mm screw in there or something. But yeah, we'll just go with that for now. So you can see in here, this is the weight. If you do a measure on this, it's about 3 millimeters, so that's definitely enough. And then we'll just use the thread tool to specify that's a thread. So Fusion actually auto-detects the thread based on the diameter, so it knows it's an M4. So one thing you can do is you can right-click and drag up. So if you right-click, it goes into like this quick select menu, and you can repeat the last thing you did. So I'll just repeat the thread again. And that's how we will mount our weight into our case. All right, I guess the next thing we can do is we'll do the screws to mount the top and the bottom case, the top and the bottom of the case together. So let's hide the stuff we don't care about. So to do the mounting, I usually don't like to have my case at an angle. So you can either delete that angle from before, but sometimes that messes some things up. So another thing you can do is just select everything, move, and you'll just rotate it back 7 degrees. So we'll hide the weight, we'll hide the plate, and then we'll just do a sketch on here. So instead of doing a sketch right on it, usually I do an offset plane again. I use offset planes quite a bit. I'll just go like 20 millimeters off, and we'll do a sketch on here. So this plate is, it's like this plane is parallel with the plane of this portion of the case. So we want our screws to go basically straight down this way. If you do the screws off this plane right here, they'll kind of go in at like a weird angle, and it doesn't really make sense. So we'll project this geometry. So I'm going to be doing M3 screws. So I'm going to do M3 of the screw type I looked at earlier, which was the socket head cap screws. So I'll just do a head cap M3 screw. I usually like to get UXL screws, so we'll just use them as a reference. So if we look, let's see if I can find the head size. I don't think it's 5. I think that's too small. There we go. 6. So it looks like the head size is 6 millimeters. So I'll make it a little bigger than that. So so if you remember, this circle is this reference point is based off the rounding of this edge, which is 4 millimeters. If we want the size of the edge of the case, we can project this edge right here, and we want our screws to sit basically in the middle of these 2 lines. So we want our screws to sit on this line. So they can sit in the middle. some problems you can run into, like if I'm doing a 6mm screw, then obviously you don't want that to be on this outside edge of the case, right? So we actually have more space down this way. So if we just offset this like a millimeter, the head of the screw only goes in a very small bit. So like, let's see if I can explain this well. So like the head of the screw will only go in like a little bit into the bottom of the case. And if you remember the design for the bottom of the case, like where I cut this out, there's some space in between here and here, about 3mm. So we can make the head a little bigger and we can move it in a little bit because there's a bunch of metal here, and we can just take the like M3 thread that's only 3mm and send it a little off of the center and everything will be fine. It might make more sense when I actually do it. It's a little hard to explain. So I think I said I was going to do 6mm. So let's take this down a little bit more. Let's offset. All right. Actually, that might end up running into this. Let me see. Yeah, okay, so I'm gonna move this up. There. So we should have space in every direction. All right. So now I'm going to find the center of the case. Is that it? I guess that's it. And I'm just gonna mirror the screw. So it'll be in the exact same place on the other side. And then I want to measure the distance between these two. 308.75. So we'll get out our calculator. Divide by 3. All right, coffee. Have a good night, man. And then we'll do one more. And now we have our 4 screws. And then the next thing we want to do is mirror them across the middle of the case this way. So we'll just copy those 4. 1, 2. And we'll mirror. And then this is our mirror line. All right, that is definitely not the middle. All right, that'll work as our mirror line. So we'll grab all 4 of those. We'll select our mirror line here, and there we go. So now we need to cut a chunk out of the case for the screws to sit in. Let's just do 25 for now. Alright, so that's probably gonna end up being too big. We're gonna have to do the screws separately. Like the front and the back screws are gonna have to be done separately. And I might have to use M2 screws instead of M3 for this case design. So that's pretty easy to change. We'll just change to 4 millimeters. Yep, smaller head size. And then I think they just need to be moved up a little bit. So I'll move all of these up 0.5, and then these ones are just mirrored, so we don't have to move them all. So if I stop the sketch, then we should see all of those, and it looks good. Alright, so now we will do the threads. Or, yeah, we'll do the actual screws. So we'll just project those circles so we have a reference point for our whole action. And we'll run the whole command. So this time we are doing M2 screws, so like, actually we already have the space for the cap of the screw. That'll just sit in there just fine. So we can actually just make the hole for, yeah, one sec. Let me reset the orbit center. All right, now we'll run the whole command. Alright, and then we just need a simple one. And this is an M2 screw, so we could just do 2 millimeters. And we just want it to go a good amount into the top of the case. So let's just say 10. So we'll do 11 so we can use 10 screws that are 10 millimeters long. So then the head of the screw will sit in this space, and then the thread will go through all the way in through here. Let me see how big this is. So 2.7. So I can actually change this extraction to be 24.5. And that'll just give us a little more space here. So that's, so we'll thread all of these. You can only do one thread at a time for some reason. Maybe I'm wrong, but I don't know a way to select multiple holes to thread. All right, The next thing I'm gonna do is I'm gonna make the cutouts for the bump-ons on the bottom. So I'll project this. So bump outs need to be like 8.1 or 8 millimeters. So I'm just gonna make it 5 millimeters from both edges. And then we'll do another 8 millimeter over here. And again, it'll be, which edges did I do? Yeah, the outside, okay. So 5 millimeters and then 5 millimeters. So those are the two bump out cut-ons there. And then I'm just gonna put them in line, the ones down here. And again, we'll do the 5 millimeters. So that's a little too close. Since this chamfer is a little thicker than this chamfer, so we can just do 7.5 to keep it on the same scale. Actually, that looks a little silly. We'll do 6. We'll do 6.5. I think 6.5 looks good. Right, and now we can extrude the bump outs, or sorry, the bump ons, not bump outs. Yeah, actually you don't even need bump ons. I mean, you could just extrude it this way and you could have your keyboard on a little platform. No, just kidding. We need to do a cut. There you go. And now you have a place to put your little bump ons, so your keyboard doesn't slide around. And then we'll just reset the orbit center again, because it gets out of whack sometimes. So you notice that I have like a lot of stuff in my history and it gets kind of hard to see things. So one thing you can do is, you can group stuff. So if I just take this, my mouse is messed up and it keeps doing this, like, it keeps double clicking when I single click. So you can create a group. So there I just grouped all of the actions to create these holes. So if I suppress those features, you'll see that the holes I created disappeared, but nothing else changed. So we can unsuppress and the holes return. I don't know if there's a way to name groups, but yeah, it's just one way you can clean up your stuff. So next, what should I do next? I guess I'll do the plate mounting. All right, I guess someone else has to get promoted to moderator. All right. Kana Joe is now a moderator. Good luck. Oh, I guess I missed one edge for the fillet, so this needs to be 1 millimeter as well. Alright, let's do the... No, we're not doing a gasket mount. This is going to be a top mount. I'm not going to do a gasket mount on stream because I don't want to design it off the top of my head. So I'm gonna center the mount on this switch cutout, right? So there's going to be a mount centered on these set of switches. So for my mount, I'm going to use an M2 screw, which will have a 4mm head. The other thing you need to make sure of when you're doing your plate mount is you don't run into your screw mounts for the case, because you can't put 2 screws through one hole. That's just not going to work out. Alright, so the head is going to be 4mm. And the distance from here, let's just do 3. So we'll do 2.5. Alright. Who's getting banned? Stop banning people. Alright, now we need to create something to hold this screw, like a little piece of plate. So go 2.5, we'll go 2.5, and then we need to project the edge. Right, so basically we're gonna have some chunk. I don't know why. Where's the sketch plane? Oh, I see. I created it there. Alright, so the first thing I'm gonna do is just gonna add this to the plate. Like that, right? And then if you want it to not look terrible, you just fillet it like that. Or I could do like 2. Yeah. Oh, so actually I think earlier I designed it so that I could have the hex cap screws sit in this area, so I can actually just make this a 2mm radius. So that's just one. We need them, like, we need one here, here. I think I'll do 4. Yeah, I think I'll do 4 or 5. I think 4 is good. Alright, so basically I need to go back to this sketch. And then I'm just gonna copy all of this geometry. 7 mounting points. Actually, that would be interesting to have 7. Maybe I'll do that. Wouldn't 5 cause issues with the USB? It would. Let me just make sure. So 7.5. I need to do the distance and divide it by 3, I'm pretty sure. And then sometimes I'm able to mirror the mounting points across the case. Sometimes it doesn't work for me, so I'm going to try it and we'll see if it works or not. Just wait for that. And then I think the distance was 285.75. 142.875. Alright, so now we have our 7 mounting points. So I'm just going to extrude all of those to add them. And then I'm going to fillet them all so that they don't look terrible. No, I did not see the Fiel or Figel Pro mounts. So there you go. Some nice round mounts. It's a plate. Alright, so now we need to extrude this from the case. So we just offset the outside by, just do 1. And then just go straight down. So what this is going to end up looking like is if we take the top, we're just going to extrude basically this out. Okay, that's too big. We're just going to extrude these, and then I need to make a line here. That. Except this part too. And it has to go both ways. Alright. Like that, right? But it needs to go up and it needs to go down. So what you can do is you can do 2 sides. The other way it needs to go, this way it needs to go 1.5 because that's the thickness of the plate. So yeah, if we hide the plate, we have a nice cutout. So basically we just need to repeat that for all of our cutouts. So yeah, we'll just do that real quick. Yeah, so you can see as I get later into designing, as there's more and more pieces, Fusion 360 starts to lag. I don't know why. It's just bad software. My computer's actually pretty good. I have a Ryzen 7, so I think the 16 thread should be able to handle this program, and then I have a GTX 1070. It's not the software. Okay. The history. I don't know. I haven't seen the code, so I can't really say if it's the history or not. I see. Well, I really like the history feature, so I don't think I'm going to be turning it off, but you don't mean? Oh, I see. Just combining steps. I mean, yeah, I guess that's one way to do it. Alright, let me just make sure I have everything that I need. And then we'll reshow the, and we'll cut this way, and we'll do the two sides, and then we'll go this way, 1.5. Oh, my bad. One sec. Let me redo that extrusion. But this time I am going to hide the plate, like I should have. And then there you go. You have plate mounting. Exciting. All right, so I guess I need to make the holes for the screws to actually go in. So we'll just project that geometry. We'll select all the center points. And then we'll look from the edge to see how deep we should go. I think 8 would be good. We'll do 7.5. And yeah, you can thread these again. Apparently I need to make them a little smaller because I'm getting too close to the case screws. I can go back and do that in a second. I thought I fixed that, but alright, let's find the sketch where I did the offset. Is it this one? No. I think it was this one. And then I just need to find that dimension. Just change that to 0.25. And this is why I like having the history feature, because I can just go back to change something and then it will propagate. So I don't have to redo everything. So yeah, history is really nice for doing case design. So yeah, we have a keyboard. I guess I could do some renders. set some materials, or set the appearance, do a matte brass. And then, which top two screws? Oh, these walls? Yeah. I should probably move it at some point, but alright, that's pretty easy to do. Let's see. Alright, so I think I just need to move. Just move that one. And move that one. All right, all fixed. And then we'll do, I like the texture of bead blasted aluminum, so I'll just put that in and then I'll change the Pantone. And then we can just do a render. Change some camera settings. Just do, so to make it more realistic and show like the little line, we can just move the case up like 0.1 millimeters, and that'll give us the line between the top and the bottom. Yeah, so these are some Fusion potato renders. Let's see. I should probably change the lighting to be less shitty. So yeah, there's a keyboard. How long is it? A little less than 2 hours, I think. Hour and a half or so. Oh, I can't render and stream at the same time? Oh, okay. That's funny. I guess it, oh, I think it just demolished my CPU. Yeah. Let's see. Is the stream